Okay, so as I said, this next video is on division, and at the end of the day, you don't have to remember all of these things. At the end, I come up with a nice, easy formula at the end. So look, at this stage, I think just watch, and then at the end, just copy down the really simple formula for division. Before we can calculate division, we have to consider what's called an inverse. So an inverse of z is sort of like the opposite, but we denote it as z minus 1, okay? So z times z minus 1 equals 1. So basically z is the same as, the inverse is the same as the reciprocal of z, okay? But as I said, you don't need to worry about this because it comes out to a nice neat formula at the end. Okay, so moving across. Okay, so let's look at an example. For instance, I know that the the complex number multiplied by the inverse equals 1, and I don't know, for instance, what it might be at this stage. So I'm just going to make up a complex number 5 plus 3i. So using your multiplying skills from the last lesson, we're going to multiply 5 by a, so that's 5a. I'm going to multiply 3 by b and then change the sign. So the real part is 5a minus 3b. The imaginary part is 5 times b and plus 3 times a. Now when I look across, this number's real and that's a real number, so the real part is 5a minus 3b equals 1. Now this is imaginary, but there's no, it's like having 0i, so there's no imaginary part, so that means that 5b plus 3a equals 0. Now what are we going to do is we're going to solve these algebraically. So I'll line them up like we do in simultaneous equations. So 3a plus 5b equals 0. It doesn't matter which one we're going to do. I'm going to eliminate a. So I'm going to multiply that equation by 3. So 15a minus 9b equals 3. I'm going to multiply that by 5. So 15a plus 25b equals 0. So that's okay. Now, I'm going to eliminate a by subtracting, and I'm going to subtract uphill so I end up with positive b's. So 25b minus 9 is 34b. 0 minus 3 is minus 3. So b equals minus 3 over 34. And then once you've got that answer, we can just sub that in. So we've got 5a minus 3 times minus 3 over 34 equals 1. So I'm just subbing it into that equation. So 5a plus 9 over 34 equals 1. And then take that across the other side. So 5a equals minus 25 over 34. And then a, it will just be divided by 5. So divide that by 5. So end up with minus 5 over 34. And so, in this particular case, for this example, the inverse is going to be, we said a plus bi. So it's going to be minus 5 over 34. Actually, that should be a plus sign. Sorry, guys. That's a plus there, and that's a plus there. Because when you subtract, you end up with a plus number. That's my fault. So that's a plus minus 3 over 34i. And so it ends up being 5 minus 3i over 34. Okay, so that's the answer to that one, but we're going to generalize it on the next slide. So sorry about that mistake there, that's a plus, that's a plus. And so we started with, we had 5 plus 3i for z, and then its inverse became 5 minus 3i over 34. Okay, so what we're going to do is we'll look for a pattern between those, and that's what's going to happen on the next slide. So let's have a look. Come across when you're ready. Okay, so in general, there's a few things we need to look at. So there's my first complex number. Now, I'm going to define the same complex number with the opposite sign. So if I've got a plus here, I'm going to put a minus here. And how do you denote it is you put a line above z. And this is really important. That's called the conjugate. So if you just change the sign, that's called the conjugate. And the other thing, which is not important right now, this word modulus, like you put absolute lines, they're not absolutes, but you could call them absolutes for the time being, the square root of a squared plus b squared. That's going to come up later in another form. But just to put a few words in conjugate and modulus. But in general, from that previous one, we had z equals 5 plus 3i, and the inverse was 5 minus 3i on 34. And what you'll find is the inverse is always the conjugate of z divided by a squared plus b squared, where a was 5 and b was 3, so 5 squared plus 3 squared equals 34. So the denominator always ends up being a squared plus b squared, which is the modulus squared. Okay, so a squared plus b squared square rooted is called the modulus, but on the bottom it's not a square root, it's just a number. So let's have a look on the next slide. So copy those down and come across when you're ready. Okay, so looking at multiplying a number by its conjugate. Okay, so we've got a plus bi multiplied by a minus bi. So we're leading to division, but we've just got to go through these steps. So we end up with just multiplying out. We get a squared plus b squared, and the real part, imaginary part, just disappears. So when you multiply a complex number by its conjugate, you get this a squared plus b squared, which was the denominator of z minus 1. Okay, so this a squared plus b squared is the denominator, and again it's going to come up again and again, but when you multiply a complex number multiplied by its conjugate, you actually get a real number, because a squared plus b squared has no i's, so a complex number by its conjugate is a real number, and that is super important to know. Okay, but still, we're still leading to division, but I'm just saying in terms of important things. A complex number, this complex number by this complex number is the only time you get a real number. Every other time you get a complex answer, but when you multiply by a conjugate, you get a real number. Okay, so coming across, we're nearly ready for the division definition. Okay, so now we're trying to get to the definition. So in terms of the definition, the inverse from about 2 pages ago, the inverse of z was the conjugate of z. Okay, the conjugate of z divided by this a squared plus b squared. Now, just on the previous page, we learned to get this a squared plus b squared, we multiply the complex number by its conjugate, and you can see that the complex numbers, the conjugates cancel out. So the inverse equals 1 over z, which I think I did a couple of slides ago. Okay, so we're finally up to division. So if I've got z1 over z2, that's the same as z1 times 1 over z2. Okay, now just here, I said if you've got 1 over something, that's the inverse. So 1 over z2 is the inverse of z2. And on the previous slide, I said that the inverse also equals z2 over z2 times z2 conjugate. Okay? And so in the end, this is the only thing you have to remember. All the other work just leads to this page, this formula. To get division, you put z1, you multiply by z2, and then you multiply by the z2 times its conjugate. So we'll see what that looks like on the next page as an example. So copy that down. So if I'm going to find 2 plus 3i, okay, so I've just noticed I've made a little error back here. So that's going to be conjugate. So it's going to be the conjugate there. So z1 over z2 will be z1 times z2 conjugate over z2 times z2 conjugate, because then you can see that the conjugates cancel themselves out. So you still end up with z1, z2. So sorry about that. So that's just a little error. So make sure you fix that. So looking at an example, what we're going to do is we multiply by the conjugate, which is going to be 1 plus 4i, and we divide by the same number because then we haven't changed the question. Okay, so across the top we can now just do an expansion. So 2 times 1 is 2, 3 times 4 is 12, and then change the sign, and then the complex part, 2 times 4 is 8, 3 times 1 is 3 times I, divided by, this is going to be a squared plus b squared, so it's going to be 1 squared plus minus 4 squared, and so your division is negative 10 plus 11i over 17. So all we do is we're just multiplying top and bottom by the same thing, which is the conjugate over the conjugate, because these two numbers, when you multiply, become a real number. Okay, and that's the end. So there'll be plenty of practice on division, and that's one of the harder things you have to worry about. Okay, bye.